All right, going to run through a quick review of sections 9.1 to 9.3. Our EQ is basically the same for the entire chapter. How can I write recursive and explicit formulas for both arithmetic and geometric sequences? So we're going to start with a little warm up here, kind of just hit on all the bases, and we're going to wrap, like, the point of this video is make sure we have everything wrapped up and we're good to go. So find the next two terms of the geometric sequence. So we know it's geometric, right? That's given in the problem. So we know the pattern is some sort of multiplication. So it's 1/3 to 4/9 to 16 over 27, 64 over 81, so on and so forth. We haven't seen too many sequences that have fractions in them. But if you notice on top, we're multiplying by 4 over and over again. And on bottom, we are multiplying by 3. So you might ask, well, what does that mean for the pattern? Obviously, I can keep this pattern going to get the next two numbers, to get the next two terms. 64 times 4 is 256. Over 81 times 3, that's 243. So there's my next term. Okay, so take that, put that there. And then if I were to find the term after that, do that same pattern, I will get 1024 over 729. There we go. Okay, so that's those are the next two terms. We know a sub 1. Remember, a sub 1 just means what's the first term, and I see that's 1/3. But then the R value is what's the pattern? What am I multiplying by? Well, I'm multiplying by 4 on top and 3 on bottom. So the common ratio is simply going to be 4/3. But if you didn't know that, we learned that in order to find the R value, you just take the second term divided by the previous term. So what I could do is I could take the second term, which is 4/9, and then divide by the first term, which was 1/3. And I'll get this decimal 1.3 repeating. If I go math, enter, enter, that gives me the same R value of 4/3. So that's another way that we could find to find the pattern if you couldn't really tell what to do there. So our recursive formula, remember, basically says, how do I get the next term based on the previous term? So we're always going to start like this. Okay. A sub n, how do I get the nth term based on the n minus first term, meaning the term before it? Well, I'm just going to multiply by 4/3. And I have a starting value of 1/3. 1/3. And that's it. That's the recursive formula. Remember, recursive is not really helpful to find future terms. But that, as far as writing a recursive rule or a recursive formula, there's that. The explicit formula, on the other hand, is a little bit more in depth. We would say to get the nth term, you're going to start at 1/3, which is a sub 1, and you're going to multiply by 4/3 over and over and over again, times 4/3, times 4/3, times 4/3. And we know that if we want to find the nth term, we need to multiply by 4/3 n minus 1 times. So n minus 1 is our exponent there. So we've got basically everything here. First term, the common ratio, the R value. We've got the next two terms. We've got the recursive formula and the explicit formula. So that's kind of everything that we need for this geometric sequence. So let's just recap how to find missing terms real quick. If you know it's arithmetic, so you know the pattern is adding or subtracting, there's two ways to do it. I'm going to show you both real quick. 18 plus some common difference plus some common difference. So I don't know the middle number, but I know that when I add the common difference twice, I will end up at -4. So one way you could do this is 18 plus 2D, because I'm adding the common difference twice, equals -4. You could then solve this using algebra to get to get the common difference. So 2 times the common difference is negative 22. Divide by 2, and I get the common difference is negative 11, which that's great. That doesn't tell me the answer here, though. So it does tell me that I'm going down 11, down 11. So 18 minus 11 would give me 7 then for that missing term. So a little bit longer of a process, okay? Like this is method number 1 to find the common difference, and then I can apply it. The other way to do it, if you're just missing a term, is to find the arithmetic mean, or basically to find the average, what you've learned as the average. And to find the average of 2 terms, I could take 18 and add negative 4, and I'm going to just divide that by 2. So 18 plus negative 4 is 14. 14 divided by 2 is 7, which is our missing term. Now, this method, it allows us to jump right to what is the missing number. What it doesn't tell us right away is what is the common difference. So it really depends on what you're looking for. If you just care about that number, you can use the bottom, this arithmetic mean. And if you need to know the common difference, it might be easier to set up an equation like in the top one. Very similar if it's geometric, but we know geometric is multiplying. Same 2 methods. I'm going to see this is times r, that's times r. So from 36 down to 16, I'm multiplying by r twice. So 36 times r squared equals 16. Okay. Then I'm going to just, not minus 36, because that's 36 multiplied. So I need to divide by 36 on both sides. R squared equals 16 over 36. I can then square root both sides. And what's nice about this is that since I'm square rooting, and 16 and 36 are both perfect square numbers, I can just square root the top and the bottom individually. And that gives me 4 over 6. Or I could then reduce that to 2/3. So R equals 2/3. Again, okay, great, I have the pattern, but I still don't have the actual answer. So I'm going to go I'm going to take the first term, which was 36. I'm going to multiply that by 2/3. 36 times 2/3 gives me 24. 24, yep. So come back here. Okay. So then I know missing term is, I know this is times 2/3. 2/3. This is 24. Okay. Again, longer process, but it tells us now we know both the pattern, aka the common ratio, as well as the missing term. The geometric mean is the way to find that middle missing term. Also, technically, we'll get to that in a second. So the geometric mean is where you take the numbers and multiply them on either side of your missing value. So 36 times 16, then I'm going to square root that answer. So if I square root 36 times 16 in the old calculator, I'm going to square root 36 times 16. These parentheses aren't necessary on this calculator, but on some of the TI-83s there are. And we also get 24, which we should have expected because we already knew the answer. So this is the square root of, who cares? 36 times 16. It's at 576, yeah. So the square root of 576 gives us the missing term of 24. Now, technically with geometric, there are 2 possible answers since we are square rooting. So back here when we got 2/3, the common ratio could be negative 2/3. Okay, so it could be, which means that possible answer for that missing term could be positive 24 or negative 24. And sure enough, we get the same thing if we look down here. The square root of 576 is technically plus or minus, but as long as you have one of those numbers, you'll be fine for that. So that is finding the missing term if we've got a geometric or arithmetic sequence. So again here, now in the warm-up, we were told it was geometric. And so we're just going to practice real quick. What if you don't? What if you're not given? 4 to negative 20, I see that's times negative 5. If I test to see if I keep going, sure enough, negative 20 times negative 5 is positive 100, and that keeps going and going and going. So I'll keep that there. Sequence type, geometric, which allows me to write the recursive formula, which says to get the nth term, you're going to take the previous term, multiply it by negative 5, and you're going to start at what? Positive 4. Okay, so there's our recursive formula. Our explicit formula is going to say, well, if you want to jump to any term, you're going to start at 4, and you're going to multiply by negative 5. Again, n minus 1 times. Because if you want to get to, like we see down here at the bottom of the screen, if you want to get to the 10th term, you are going to have to make 9 jumps of negative 5 when you start at 4. So to find the 10th term, I'm going to use that explicit formula. We're going to take 4 times negative 5 to the 9th power. This is going to be a large number. 4 times, now you do have to put negative 5 in parentheses most of the time, or exactly half the time. So negative 7.8125 million. So a sub 10 equals negative 7,812,500. Okay. So there's our 10th term of that sequence. We actually already did this. A sub 1 is 4, and the pattern is multiplying by negative 5. Okay. So there's that for a geometric sequence. This one, 12, 5, negative 2, negative 9. We can test for arithmetic. 12 to 5 is down 7. 5 to negative 2 is down 7. Negative 2, negative 9 is down 7. So I know this is arithmetic. Arithmetic. Recursive formula is going to say to get the nth term, take the previous term, and you're going to subtract 7. And our first term is at 12. Explicitly, I would say to get the nth term, you're going to start at 12. You're going to minus 7 and minus 1 times. Now, again, it's important to remember if it's arithmetic and it's adding or subtracting, you're going to multiply by n minus 1. Whereas in the previous example, if I want to multiply by the same thing over and over again, I have to use an exponent. Okay, so that's probably the trickiest part that students struggle with, is that we have the n value is being multiplied in the explicit formula for arithmetic. Finally, here to find the 10th term, I'm going to take 12 and subtract 7 9 times. 12 minus 7 times 9 is some number that we're about to find out. 7 times 9, 63, negative 51. So here the 10th term, a sub 10 equals negative 51. And then our first term was 12, and our pattern was down 7, or subtracting 7. So there's a recursive and explicit formula for a arithmetic sequence. This was the graphic organizer that we made in class of the recursive formulas for both types of sequences. So you can look over this stuff. Again, that's not going to be given to you on the test, so you will have to know it. But I think with enough practice, it does get to be second nature and kind of makes sense what to do. The optional review homework is 604, 15 to 35. The word optional, meaning that it is not being collected. But those are the 3 homeworks that are due when we test on 9-1 to 9-3. So that was a quick little review. Hopefully it helps, and we'll see you